Alright, you are welcome to this video, and in this lesson we have been asked to use the derivative definition to find the dy dx of this function f of x equals x squared. So let's do that. So what is the definition to begin with? It defines that f of x, f prime of x, is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. This is the formula for the definition. And how did we get this? Now let's pay attention. Now here we know that our goal is that we want to approximate our secant line so that it gets so close to our tangent line, and at that point we can find the slope. Now we take this as our x1. If here is x1, your corresponding y value is in pair. We have x1 and we have f of x1, right? That's good. Now, if I move a distance away from x, let's say I move to this point here, x, a distance away from x. Let's call that distance h. So if here is x1, here should be x plus h. And the corresponding value here should also be what? X plus h. And what? F of x plus h. Yeah, so that is the idea. So the idea is to approximate this man so close so that it can become tangent line. That is, pushing h to 0, making it so small, so little that it's just approximate to the tangent line here. So you just imagine I put h as 0 here. Here becomes f of x. What is here? That is right. So let's go. So we have, the definition says that f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. Now, what do we have? We have that our f of x is equal to x squared. But we need f of x plus h. Now, if here is f of x, then f of x plus h will be equal to, anywhere you find x in the expression, put x plus h there. So here we have x plus h squared. And we know that our f of x is our x squared. So we can put all this here in this function. So let's go. So f prime of x is equal to the limit as h approaches 0 of x plus h squared minus x squared, the function, all over h. Alright, so with this, we can expand this function by, we have f prime of x is equal to the limit as h approaches 0 of, to expand that, we have x plus h, another x plus h, minus x squared, all dividing h. So let's expand that. We have f prime of x to be equal to the limit as h goes to 0. X by x will give us x squared. S by h will give us hx. H and x will give us another hx. And we have h by h should give us h squared minus x squared, all dividing our h. Okay. So at this point, you see it is clear that we can cancel out our x squared and our x squared, leaving out what we have left. So we have hx plus hs plus h squared. So this becomes f prime of x is equal to the limit as h tends to 0 of hx plus hx plus h squared all over h. That's what we have at that point. So hx plus hs is 2hx. So f prime of x is equal to the limit as h approaches 0 of 2hx plus h squared all over h. At this point, all you have to do is divide through by h, and we have h cancel out h, the same h cancel out h here. So we have f prime of x is equal to the limit as h tends to 0 of 2x plus h. So at this point, the moment you divide, at this point you limit your h to 0. So let's limit our h to 0. F prime we have 2x plus 0. So f prime of x is equal to 2x using our derivative definition. So thank you and see you in the next lesson.